Hello there, Mr. Sutton here with the Pre-Cal Honors 8-2 Extra Practice Number 1 solutions on geometric series and sigma notation. On this problem, I'm trying to find the 10th term of a geometric sequence starting with 1/3. So let me write out my formula. We have a1 times r to the n minus 1, giving me that nth term. a1 we already know is 1/3. For r, we have to do a2 divided by a1. So 1/6 divided by 1/3, that'll tell me what my common ratio is, what I'm multiplying by each time. To do this division, I need to multiply by the reciprocal, so I really have 1/6 times 3/1. 3/6 then gives me 1/2. And then plugging all that in, we've got 1/3 times common ratio of 1/2 to the 10 minus 1, and let me do that on the calculator now. So I made use of my calculator's fraction mode to kind of handle the fractions on this, and that's going to come out to 1/1536. Fraction mode is your friend. On this problem, I want the sum of the first 8 terms of this geometric series. Now, I could write out the next few terms of this because I can definitely see the pattern that's going on here, or I could just use the general formula, a1 times 1 minus r to the n all over 1 minus r. So my a1 in this case is going to be just this first term of 4, and then I'm doing 1 minus the common ratio to the n. So common ratio, let's see, we're multiplying by -2 each time to get the next term, and then n in this case is this 8 because we want the sum of the first 8 terms. So we have 1 minus -2 in a parentheses raised to the 8th power. All of this over 1 minus -2 or 1 plus 2. And I'm just going to do this on the calculator now. So if I run those numbers, that's going to come out to -340 for this one. For this problem, I want the sum of the first 9 terms of a geometric series whose first term is -2 and whose common ratio is 3. So let me set up my general formula here. That's going to be a1 times 1 minus r to the n all over 1 minus r. a1 they gave us, that's -2. r is 3. n in this case is 9. So we have -2 times 1 minus 3 to the 9th all over 1 minus 3. And I'm definitely going to do this one on the calculator. So plugging all that in using fraction mode, which is just alpha y equals, that's going to come out to -19,682. For this problem, this is kind of weird. I'm trying to find the summation from -3 to 1 of negative absolute value of 4n. So basically, I'm plugging in all the integers from -3 to +1 into this expression and adding all those together. So for my first term, I've got negative absolute value of 4 times -3. So that would be -12 in the absolute value there. And then we have plus negative, this will be -8 now in absolute value. Then we're going to do -1 inside here. So this is minus absolute value of -4. Now we plug in 0, so minus absolute value of 0. And finally plug in 1, so we're subtracting the absolute value of 4. Well, this is going to be, let's see, -12. Minus 8 is going to be -20. Minus 4 is -24. 0 makes no difference. We're subtracting another 4 to get us all the way to -28. For this problem, we want the sum of the series n times n minus 2 from 1 to 5. So we're going to start at n equals 1 and just plug that in and add things together until we get to 5. So I've got my first term is going to be 1 times 1 minus 2. That's 1 times -1, which is -1. For the next term, I'm plugging in 2. That's 2 times 2 minus 2. Well, 2 minus 2 is 0, so that whole thing comes out to 0. Then I've got 3 times 3 minus 2. That's 3 times 1, which is 3. Then we have 4 times 4 minus 2. That's 4 times 2, which is 8. And then finally, we have 5 times 5 minus 2. 5 times 3 gives us 15. Adding all that together, we've got, let's see, this is -1, 3 comes out to 2, plus 8 is 10, plus another 15 gives us a grand total of 25. On this problem, we're going to try to find the summation from 7 to 28 of 5k And we're going to try to do it without using the summation button on the calculator. So let's start writing out the terms of this series. We've got 7 times 5, because we're plugging all the numbers from 7 to 28 into k here. So 5 times 7 is 35. Then we do 5 times 8, which is 40. 5 times 9 is 45. And there's a whole lot of terms here, going all the way to 5 times 28, which is going to be 140. So rather than write all those out and add them together, this is actually, if you look at what's happening here, we keep adding 5 each time to get the next term in the series. So this is an arithmetic series, and we can use our arithmetic series sum, n times a1 plus an over 2, to get the summation of this. So n in this case is going to be, well, let's see here, from 7 to 28, that's 22 terms. a1 is 35. an is 140. So let's just plug all of those into our calculator now. And that's going to come out to a grand total of 1,925. For this problem, we want the summation from 5 to 65 of negative 1/7 to the k power. Now, before you start plugging in 5 through 65 and trying to add all those together, this is a geometric series. We keep multiplying by negative 1/7 over and over again. That's what this exponential variable is telling you. Since it's geometric, that means we can use our geometric formula, a1 times 1 minus r to the n over 1 minus r. a1 in this case is going to be, well, let's see, if we plug 5 into this, we get, well, negative 1/7 to the 5, whatever that comes out to. I'll let my calculator figure that out in a minute. The r value, the thing that I keep multiplying by, is negative 1/7. And then finally, n, how many terms are there from 5 to 65? Well, that's going to be 61 terms. It's always 1 plus whatever the difference is between these. So 61 for n. So plugging all this in, we can say the sum here is going to be negative 1/7 to the 5th times 1 minus negative 1/7 to the 61 power, all over 1 plus 1/7. So all this craziness, which I will now attempt to enter on my calculator. So here goes nothing. I used alpha y equals n over d mode quite a lot for this. I have actually 2 levels of fractions in this one. If I press enter, all this craziness comes out to about negative 5.206 times 10 to the negative 5th power is what that means. On this problem, we're trying to turn this series into sigma notation. So let's start by figuring out what ties all these together. These are all perfect squares. This is 3 squared, 4 squared, 5 squared, and so on. So when I'm writing out my summation, my summand, to get perfect squares, I'm going to need n squared. What's the first thing I need to plug in for n to get 9? Well, that would be 3. So I'm going to start with n equals 3. And then we've got 49 as our last term. That's really 7 squared. So 7 is my upper limit of summation. For this problem, I want to turn this series into summation sigma notation. What do these all have in common? 10, 15, 20, 25. These are all multiples of 5. So when I write my summation out, my formula should be 5 times n. So what's the first thing I need to multiply by 5 to get my first term? Well, to get 10, that would be 5 times 2. And then 5 times 3 would give me 15. 5 times 4 gives me 20. My last term, well, this dot, dot, dot means this is going to infinity. So I'm just going to write infinity as my upper limit of summation. For this one, I'm trying to rewrite this series with sigma notation. So the commonality between all these are all just powers of x. So let me write the summation of x to the n. And the first n value I want to plug in is 4 to get x to the 4th. And then this goes all the way to infinity. So my upper limit of summation is going to have to be infinity.